Alright, we are live. Cool. We have 0 people on the channel, which is very nice. 2 people once they see it. So, hello everyone for the recording. This is the Ethereum Engineering Group meetup, and Lucas is going to talk about Solidity. We're about 10 minutes before the meetup starts, so you might want to skip the video for about another 10 minutes.
How's your stuff going, Scott?
Busy. Lots of problems to fix.
It's insane at the moment. You can get this up. Is there anything to get this up higher?
I'm writing a paper at the moment.
Yeah, that might be enough. Beautiful.
Yeah, I knew that. And yes, I do feel that. That's why I know that it's
I'm in town for 2 weeks. So maybe
Just want to check the space settings.
Yeah, quite a few things there.
one thing I
May not be sensitive.
yeah, but that kind of thing don't help. But yeah, hopefully let's have a chat in coffee or something. Send me an email and we can not have your email address.
you've got it.
I'll probably do that.
She's pushing out. One's like, I'll write one around. No, that was
You want to be come across as being knowledgeable. I think actually there's a teach yourself thing as well, which is called horizontal, and then there's another one which is called capture the ether, and both of those I think you could just do a research on, and I haven't actually done it, but I know a lot of people have.
Neural display, maybe?
That's why I want to chat to you.
This thing over here.
Well, I mean, this is the thing. It's really hard to get high. I'll just be able to move between platforms. it's going to be, it's philosophy. Yeah, well, we'll also live streaming the audio qualities on that camera amazing. Yeah, you can have someone fight to the back and yeah, it makes it cool. It's amazing. Yeah, it's so much easier to do you want to, live stream, do you just want to have just a video and I don't know, this and just say sure, and then, like, so what I know right start, like I said, this is what we're looking at, and by the way, if you were 10 years into the future, in fact, in the future, there's enough to have a little while where it's worked out, suddenly everything's changed.
We've got 1 minute. It's necessary, as Al CTO says, make all the big calls and also having the stress. Including the toilet.
So you
so just Brisbane Gold Coast is an easy to look out for. Taking your advice on time zones. So marketing's going to be in San Fran. That's what you
those teams need to maximise the US always wins.
Yeah, I'm up for every morning for the West Coast. But I'm
6 o'clock away.
I've got to be back in some of this tonight.
So Lucas, are you ready to go?
Yeah.
6 is a go for me.
Maybe get What about from Slack? If you can get to Google Drive, you can choose Google Drive, then you can get to the Ethereum engineering group. Yeah, right, looks good. And present. Okay. Hello and welcome everyone. Welcome to another fun-packed Ethereum engineering group meetup. With us today we've got Lucas Cullen, a Solidity guru who also runs the Bitcoin and blockchain meetup and works at Consensus and knows all sorts of stuff. So I'll hand it over to you.
Alright, thanks Pete. Yeah, a few familiar faces. Alright, so today is, as it says, Introduction to Solidity. So I'm going to do a bit more code, Solidity by example, a little bit less slides. So I guess the opening is, what is Solidity? I stole this from Pete's slides, from the first one, so high level language, which compiles down to these bytecodes. So when we had Rob Dawson's talk, he mentioned about the opcodes, etc. in the Ethereum VM. So for me, this is my take on Solidity. The fun language is up the top, and for me, Solidity sits down there, a little bit above Objective-C and Visual Basic, not by much. So I'll point out what you can do, and I'll point out what you can't do, and hopefully, if we will, watch the language evolve, then you'll get up to speed and be on point. So for my example today is what I want to build in the next, I think we've got 40 minutes, is to build a Uber replacement on a blockchain. So we think about why use a blockchain. It always comes up, why should we use a blockchain? Why should we use these smart contracts? And it's really to, I guess, get rid of the middleman. So we think around Uber and we can create contracts between a rider and a driver, then we should ask the question, why do we need this Uber middleman? So, like I said, today's demo, we're trying to build that and show some of the features of the language as we go. So let's consider, I guess this is kind of the requirements or a rideshare scenario. So we should be able to make these peer-to-peer markets between rider and driver. The rider perhaps can request to be picked up at a location and dropped off. Drivers could then query the blockchain and say, yeah, I want to accept that fare. We can then use, if we have Ethereum-based currencies or digital tokens, we can lock up those funds in smart contracts. And then we could use something like the commit reveal schema to ensure that this can't be gamed. So the idea is you could perhaps put in a ride request with some kind of key or GUID. Once the driver gets there and drops you off at the end, you could then pass on the hash of that and release the funds to try and stop. So there has to be some physical exchange or some information exchange that's off chain to make sure those to make sure that event actually happened. It's very hard to assert did this ride happen without that. All data, GPS, etc. can be faked in. So I'm going to try and split between slides. So slides and Visual Studio Code. So we'll see how we go. Alright. So who here has used Visual Studio Code or something else to write Solidity? So pretty familiar. Okay, so for those who haven't, there's Microsoft product Visual Studio Code, which looks like this guy. And if you want to start to get into Solidity, we add these extensions. And there's a consensus guy, Juan Blanco, he wrote the Solidity extension. Okay, so just install that guy from Juan Blanco, and then you'll be away. So that's really all you need to get up and running the smart contracts. So, first off, can we all see that? Is that right?
Zoom's down the bottom.
Wrong one. Alright, so can you all see that? Is that good enough? A little bit more. Alright. Okay, so we start off with our pragma. The IntelliSense complete setup, we've got the extension, and what we're just saying is identifying what version of Solidity we want. It's actually, that's the current, but I've only got Solidity 23 on here, so I'll just put in that guy. And then we just start our contract, which is kind of like a class, or I think more like a table or a stored procedure. And I'm going to call this guy rideshare. Alright, pretty simple. So next thing we've got is data types. So what data types does Solidity have? We have your integers, unsigned and signed integers. We don't have decimals or floats, which I'll demonstrate some of the limitations. We have addresses, which can be the Ethereum address you're paying to, or your the actual address of the contract. We have bytes, which are, like I mentioned, just bytes. We can store hashes, etc. in them, and booleans. And we also have the idea of structs, which, like other languages, Java, etc., you just hold data. So what I'm going to do now is just create a struct for our rideshare. So we can just call it ride request. Okay. And then in here I'm going to have some properties. So I'm going to have so we want to lat and un to long, uint from lats and uint long. Right, so what I'm going to do there is in this struct I'm going to hold the data where when we make a request to the blockchain, we're going to store that in where we want to get picked up. So the other thing we can do with Solidity is also have enumerations, okay, just like other languages. So I'm going to create an enum to basically go through the state. So when I make a request to the blockchain, it's like waiting for a ride, the driver accepts it, perhaps riding and perhaps completed. So simply we can just put in here enum, IntelliSense gives us some hints. We can go ride state, and then we can just, like I said, whatever I mentioned, waiting, accepted, and we're doing with commas, not thingos, on route, also riding and complete. Now up in this guy here, we also then want to give it the state in our struct, so we can just do, we can now use that enum. And away we go. There we go. Cool. Alright, so pretty straightforward. So what we're going to do is hold the state of, as you go through your journey. So the next part, and I'll mention, as we go through, we'll bring into some of the other data types, the Boolean address, etc. But there you can just see some basic data types there. So the next part, when we write a contract, is we want to input data. So there's basically a few different ways we can add data. One way we should say functions. But functions there's basically three different types of functions. We can have functions that change the state of the blockchain, which will cost gas to write to the change, write a state change to the blockchain. We can have views which can read data from the contract but do not change the state of the contract. And I'll show you a good reason why we want to do that. And the next one that we just brought out in about Solidity 20 off memory, 4.20, is pure functions. So if you come from JavaScript, you might know these pure functions, which are just computational functions where they don't actually read any state or any data off the chain. So if we think with respect to our rideshare, maybe a good way to determine the price is just maybe using Pythagoras, a squared plus b squared equals c squared, and I'll show some limitations of that as well, to try and get a quote. So like I said, we want to jump into our, perhaps we want to open our app, we want to get a quote, we put it in, we don't want to consume gas, so we can just make a function, that's a pure function, and away we go. So function quote, now we also have a scope. Public is, as it mentions, can be seen by everyone, but I'll talk a bit more on scope at a moment. And we can have returns, which we give a data type at. Okay, so then we can simply put in here our params. So I won't spell it out. So x, y, I'll put something like that. Right, so they're going to be our two coordinates. And then what else we can do for a little bit more abstraction, perhaps we can make a struct of location. Sorry. And we could put in there our something like that to make it a little bit more abstract. And then obviously we can have in this struct down here, we could have a location instead of uints, just to make it a little bit cleaner if we wanted to. So, and just to perhaps save some time, I'll get that guy there, which is what I've done. Alright, so I've made them Right, so you can see where we're going with this. So to calculate the price, we just want to do, say, the delta. So we can say equals, so this is where we can start to do our basic math operations. So Alright, so what I'm doing there is trying to get the delta between the 2 points, then maybe use Pythagoras to work out the length of the hypotenuse, for example. Now we can see some of the problems here. These are ints, not decimals, so we're going to have some problems there. The other thing we notice is we don't have, in Solidity, we don't have a math.absolute, so you'd have to cater for those kind of scenarios. Obviously we want the absolute delta between them. This would probably go into some negatives. If these are ints, then things could go wrong. So what I'm going to do now is create that location guy. Let's call it the call it 2. Okay, so what I'm going to say here now is I want to create that location struct, and I'll show you how to create how to new up a new struct. Basically, all you do is you just have to, you don't use a new keyword, you just call the struct, and you pass in the parameters in order. So we've got long as top, lat as the second one, and you can actually do name parameters if you like, but for this example we won't bother. Right, so then we just create a new location object. Now, we've got a few squiggles here. The squiggles are saying that I haven't used this guy yet. And the other one here is to say that this should be of a memory type. Because I don't want to actually write this guy to the blockchain, because what I'm going to do is just use it in memory. So what I can do to get rid of that guy, it's just like a pointer in C++. Is use that memory keyword. Now it's going to complain because I haven't used that guy yet as well. Okay, so just to speed things up, here's one we've done earlier, a little bit better typed. Okay. Alright, so away we go. So the other things we'll note, I'll get rid of this guy for the moment, because that comes next. Is alright, so then we're just going to, we can't do, we can do squared with double asterisk to 2 if we want to do squared, but we'll just do multiplication like that. So we can use the math operators, plus, minus, etc. And you've got to look at rounding, etc. and errors. So there's a library where you can use math to try and make some of these a little bit safer. So next thing we note is if we get rid of this guy here, that the contract will say that we can actually make it a pure method because we're not actually writing anything to the chain. We're only doing this in computation math here, so we can make that better by writing a pure method. So then we return that guy there. Now we've got a casting problem here. So with Solidity we can also just cast via, same as like some other languages like C#, and we can just cast our object like that. Not sure why you're complaining. Alright. Yeah. Alright, so we can do a simple math operation now. We can try and get a quote. As I mentioned, this is free to read off the blockchain. So we can call the EVM and keep getting data off it with some simple math operations. As we pointed out, there's a few limitations with the math, so you can't do too crazy things at the moment. So there aren't functions like absolute. There's no function like square root. There's no trig functions, and there's no constants like e, pi, etc. So to actually calculate a correct distance, calculating the curvature of the Earth, You need to use like your arc sign or that. So to do something like that is very hard in Solidity. So you need to be thinking about that when you write your code. Okay, so we'll move along. Some other system style variables or values, and we'll introduce them into the smart contract now, is date times, block heights, and time functions. We can actually, the EVM has hash functions, both SHA-2 and was it Kanak, whatever, SHA-3, and I'll show you how we can use them in a moment. So, with respect to our application, when a driver requests a ride, we might want to put a timestamp in. We maybe have a limitation on the way that this ride is available, so we might expire in 30 minutes. Like I said, we're going to extend our contract to have a shared secret. And doing, just as another thing, limitations again, that date parts can be tricky. So if you have to do, all timestamps are in the epoch times. So if you ever have to do, say, starts on Monday or the 1st of June, it can be very complicated to do. So to show that example, we'll do a request ride function. This is going to be a function because it's going to actually write to the chain in a minute. Make it public. Okay. So functions can also call other functions. So we already have our quote function to get the value. But what we also might do is we need a price per kilometre. So Solidity also has the idea of constants, although with Uber that ride, what was it, the load, what's it called, that can price, so they can have that surcharge, but for this demo we'll just call it, or make it a constant just to show that constants can be done. So actually, we might make it infinity, so just go here, and copy my guy here. Okay, so remember back to our slides, the other system values here we can have is gas and Ethereum. So what I'm going to say in my contract here is this ride is based in 100 Finny. Okay, so we could use other values like Ether, Sabo, etc. But for this example, we use Finny. So to stop our contract being abused, we could make it check that the user has enough funds to be able to actually book this ride. So we could have, say, amount or cost. Again, we can call our quote function. There's no point doing it twice. Just copy this guy here. Okay. So we've got our quote up the top, so we can call that guy there, get it. Now what we can do is if we make the function actually payable, so it can receive Ether. So we can decorate that function with the payable method. Then when we hit this guy here, we can get the system value message.value, which is the amount in Sabo, or what's the smallest, Finny? Weight, that's it. And we can make sure that the user then has enough funds to actually book this ride, again to stop the DOSing of the contract. We can also now, with Solidity, we can have, if we don't want to use require, we can use revert with reason. So we can actually put in now a message to say, for example, so we can get some feedback as to why the contract failed. So once we've got that, and we've got past that line, so the user or the ride they've done their quote, now they want to book it, we need somewhere to store the data to the blockchain. So with Solidity, we have two, I guess, collection types. We have maps and arrays. So arrays, like JavaScript and other types of arrays, where we can iterate through them with an iterator, and we can have a property of .length to get the end of the array. And we have mappings, which are more like your key value pair. So we can assign a unique identifier to that object or to that collection to get it back. So that sometimes creates a problem. Sometimes you need to have both. So you can't iterate through a mapping, so sometimes you need to have both, which is kind of an anti-pattern, I guess, but that's the limitation of the system. So with respect to this, we may have a set of rides. We then might assign them to the user via their key, and then we might iterate through them to do some interesting stuff like perhaps history or calculate a rating. So to book this guy here, we'll just create we just need to do an array, which of our state here, ride request, put it up here so we can see it, just like that for an array. We'll make it public, people can see it, and we'll just call it rides. Really exciting stuff. So down in here, we can new up a new ride object. It's a bit hard to see. So we just new up a new ride request, and then, like I said, we just have those name parameters, or we can just put them in order. So cut that guy across. Alright. Oops. Sorry, I'll just cut all these guys here. Alright, so we get our coordinates now in the structs just for brevity. Then we won't do this guy at the moment. Then we can just new up a new ride here. As I mentioned, just throw those name parameters. But what we can also do is just use the push function. So this is the collection, so we're just pushing a new ride request into there. I could put that on another line to make it a bit more readable. And we also, in our ride request, we want to have the state. So to set that, we can just do simply ride request dot state. And on this example, I called it waiting. Okay, so we can use our enum to create this new object and push it into the collection. So then once that's done, we have the collection of rides, where then a driver can come along and pick that up and request it. So as I mentioned before, we might want to do something to just like that commit reveal process. So we can use the SHA function here, that CACAC, to pass in a code that we can show the driver. The smart contract setup will hash it, and then it'll push it into the ride request object, and then maybe when the driver and the rider meet, they could do that physical exchange of that secret to assert that the event actually happened. So I'll just copy this guy across. Okay, now get back to loops. The only other thing we want to mention is that how do we monitor the state of the blockchain, and we have what we call events. So if we think of like the observer pattern, we can have our application, if it's JavaScript, etc., watch for events. That event might be something like a new ride's been added. Our app then is notified, and we can display some data, so a driver could sit there and monitor and say, hey, a new request has been put in your area, go and pick them up. So an event is simply just event, and then I like to do kind of the opposite nounage, so request ride requested, and then we can put in here index. Okay, so then I can pass through to this event to say, hey, a new ride has been added at the index of those collections of rides. So then how we do it, how we then call that function, we used to just be able to call it like that, but with the new version of Solidity 23, we use the emit keyword. So I'm doing there is calling this guy here to say, hey, raise the notification. As I mentioned before, the rides collection has a property length, so we just want to do length -1 because it's a zero-based index to say, hey, this new guy's been added. So we can do loops. I'm just going to complete the part about the driver requesting, the driver actually accepting the ride, just to complete it. So quite quickly we can just put this guy in. So it's a pretty simple function. On the other end, we just accept booking, we pass through perhaps the index, and then we're just going to change the state. So as soon as we call this line here, which was at enumerator, we're just changing it to the enumerator to accepted. So this is actually changing the state of the blockchain, so that that object of ride request in that collection will now be accepted. So we could do some kind of assertions there, whatever, some kind of logic to make sure that we're being picked up, except something there, I don't know. So that's just a basic simple booking. We could also maybe make it payable so people can't spam and just DOS the contract, so you actually have to put down money to accept that ride as a driver. Okay, so up in my other guy here, I also thought with a ride request, so I can refactor this struct now to have some other properties in here. So like I mentioned, we can change it to use complex types, and what I might have in here is also a rating. So a reason perhaps to do a loop would be to get the user's rating. So the other collection type we mentioned was mappings, so I haven't got a mapping here. So what I might do is have a mapping where my key is an address, so that's my rider's Ethereum address, to a collection of ride requests, and I'll call this history. Okay, so each time a rider makes a request, we can assign a collection to their actual key. Now, to get that out, to make it usable, we'll make a function. Now this will be a constant function or a view because it's not going to change the state of the contract. So we can have something function rating. Okay. View returns event 256. Okay. So the first thing I want to do is get that collection out based on their key. I'll call it history, so that's the local history, and then I make that. Now all I simply do is pass in the key. So up here we've mapped a collection to someone's address, and we come back here and we just get that collection based out. Now it's going to complain because I don't have it, and I could probably put in memory as well. Okay, so yeah. Okay, so now if I can simply do a for loop, just like JavaScript. Is less than local history length, and then we can do the same as JavaScript and other languages, I++. So I'm just creating an iterator there. Then I might want to do something like up here. Then I go again, same as JavaScript, and just do like my plus equals, plus minus, plus multiply, plus divide, and I can just simply do history I dot, I think I call it a rating. Now it's going to complain because of casting, where this guy's a uint, and I think I call it up there a uint 8 because your rating might be 1 to 5, so we can just use a uint 8 to save size on the blockchain. So we might just want to do, again, we can just cast it like that if we need to. And then we can just simply here return, okay, so we can do something like that and get their rating. And it's just complaining because I haven't set the scope. Okay, so we obviously want to make that function public, so when a driver comes along, hey, what's your rating? So we could down here say have accept ride. We might do something like require, require that user's rating is above some arbitrary value. Okay, so through our process now, we've got a quote, we've booked our cab, the rider's accepted it, we've been notified of it, the users have put payment in there. So the only other thing to do is to say once we've received the destination, the driver may want to make a request for payment. So the funds have gone into the smart contract, and then, like I said, at the other end, the driver might want to say, hey, pay me for this fare. I've got the code because we made that exchange, that key exchange. I'll pass it into the contract, and I'll show you how to send Ethereum back out. So you can just function request.
So Lucas, when they were putting the funds into the contract, was that other function which was payable?
Yep.
Is the amount of money they send across equal to the quote, or it can be an arbitrary amount? As long as it's bigger than the quote, then that's the amount that's gone in.
Yeah, so what Pete said is how do we stop it? Like the payments come in. There's no real logic in this guy here to make sure it's equal, so we might have to have some kind of if over, refund, etc. We could extend our ride to say something like cost and I don't know, like that, or whatever, store it there, and then, but I never like sending back money.
Someone pays you too much, they've given a tip.
Yeah, exactly. Exactly, treat it as a tip. So, and then again, we just use that same pattern of index of the contract, and we'll pass through just as a string code, public view, because no, because we're going to change the state of the code, we won't make it as that. So then here we can get the booking out, which is, like I said, it's pretty straightforward. We can just use the index, so we can just do I'll just copy this guy, it might be easier. Right. Okay. So we can make sure up the top here that we have used, so again, use our require keyword, so we get the code that was stored in the rides collection of that index. We can then create the hash of the code to make sure they match. So the driver says, hey, this is the code I got, it goes through, the contract does a hash. If they match, the code will then proceed. Back to those system value types, we also have message.sender. So the person, we're going to assume the person calling this function is the driver. I guess there could be a gamer where the writer could also know the code and get the funds back, but for this demo we won't worry about that. So we get the address as the message.sender, And then on the address, we simply have a transfer function, which to me is like counterintuitive. I always think it's transfer to, but it's transfer from, but it's transfer to. And then we can just simply get their fee that we stored up in the contract, or like Pete said, we could perhaps store the whole ETH, etc. If we wanted to make an Uber, we could put up in here our own fee. So we could take, if we want to deploy this live, we could take our own fee, a percentage or whatever, based on the contract, the ride, and make money off this if we want to. So then, yep, that will then send the Ether on to the driver, and we are pretty much done. So, might be one more thing. That's the last bit too. So, the only other thing we can do here is what we call modifiers. We go back to our slides. Modifiers, we can abstract parts of our code to make them reusable. I see them as like attributes in other languages like C# and Java and Python. We can check for invariants like require, etc. And like I said, I'll make one for is pending. So we just use the modifier keyword. Okay. So the idea is here is have a bit of code that we could say perhaps on the accept booking, we can only accept the booking if is pending. Okay, and we pass through the index. So just to maybe stop having requires everywhere, so you'll see this a fair bit on like require only owner. Again, try and just encapsulate that logic to do it. I personally don't like this. Viper gets rid of this, so I've been doing a talk on Viper and their reasoning not to do this, but it's in Solidity, so we do it. So we can now have here like just whatever logic we want here. So then require rides equals rights state dot etc. So then we put all our logic in here, and then after that guy, that's where the code will continue from there down. So that's basically there where your require sits, or where that modifier sits. So like I said, it's just a nice way to abstract. Alright, that's just about it. So that is like building an Uber app in half an hour, which kind of maybe illustrates the power of smart contracts. We can hold funds in escrow. We don't need people in the middle to arbitrate those conditions. We might think of ways we can do it ourselves. And as I mentioned before, some of the math functions are hard. So this is one I wrote on doing your square root function, which isn't nice. But if we wanted to do that, because if we remember back to our guy here, that's not true Pythagoras, we need to do the square root of that as well. So how we can then use that guy is with Solidity. We can also have the concept of libraries, which are, I guess, bits of code that are contracts, and we can just simply import that into the contract. So just using the import statement. So there's a lot of libraries coming out now, and obviously very well tested. I think Pete's got his random number generator with one coming in. Watch this space. Maybe I've disclosed too much. And then we can just here then use that function in here, wherever it's called. And away you go. Alrighty. So that's Solidity in a nutshell. Like I said, building. Hopefully, it's kind of shown you some of the things you can do with smart contracts. Build little, decentralized applications that can reduce the use for middlemen or middle people, and then obviously you wire up the interface to this, and this is kind of just containing all that logic, and the thinking being that contract is the law, so we can read these as codes as terms and conditions as opposed to other terms and conditions, and know like the conditions we're getting into when we enter the cap. So that's pretty much it. I hope that was informative. Any other questions? Yeah, Joey?
With the memory modifiers for variables, is that only for like those complex types?
Yeah, I think strings as well,
Okay.
but not the val.
Not like the
Not-
hints and stuff.
Yeah, not the value types, the data types. I'm pretty sure. Yeah.
And also, I think in the when you're getting the rating, you use the memory as well. So is that like when you?
So this is one I did like with a bit, not on the spot. So this is probably a bit better. So I just got that, the history of the user, put it in memory, then iterate around. But yeah, we don't need to, because it's an int. We don't need to put a memory guy in there. But sorry.
I was going to say for the history, because the history capital H is like a variable on the contract. Is that technically?
This guy here.
No, so the one that you're assigning.
Oh, in this example I made, the convention is to make the public guys uppercase.
Yeah. But then, so you're using that memory modifier even though you're kind of assigning the value for the key that already exists?
Yeah, you could just do it without, you could call the other guy the mapping directly,
Yeah.
but I'm just basically pulling in here for a bit of readability, I guess. And just because I don't want to really, it's really just a pointer to the other guy anyway.
Yeah. I was just wondering like if it's the pointer, does it still need the memory one if that kind of already exists? But
Well, I guess another question, which is possibly related, is if you did use just history with the square brackets in the 2 or 3 locations you've got there, would that end up generating more EVM code, or is the Solidity compiler smart enough to realise you've just got a pointer? Would you end up with more code?
Good question. So what we can do, if we wanted to, we could put it in this guy here, which is remix. We can compile down, and then we could see the opcodes if we wanted to. I don't know, the compiler works in a funny way, so I'd be hesitant to give an answer.
Yeah, it'd be something to research.
Yeah, and if you look at the ints, actually int 8s are worse than like int 256. So we could deploy our contract using this, and then we could actually call our quote and receive some values back. And the other thing too I noticed is, doing that division can be dangerous with rounding, so you need to maybe use safe math or make sure that it's tested well, because of underflows and overflows. Any other? Yeah. Sven?
Lucas, maybe you want to mention that one point, blockchain programming is very different from standard programming. So if you use any loops, it might work out in any test case, but once you deploy it in reality, then somebody might have 10,000 writes, and you would loop in this simple case through all the old writes to accumulate this replication, and then it would fail because it would run out of gas. So that's something which is very different to a normal program, where it just might take another millisecond. In this case, it would actually crash the whole system. It might look nice during testing, but later, if it's in real production, it might break.
Yeah, so that's a good point. So Sven's just highlighting that the functions take gas to run, and there's limitations on gas. So when you have big loops and big functions, that they can stop halfway through or not run. So you might look at different partitioning ways of your arrays, and but it's a good point. And someone might, as an attack, fill the rides with lots of data just to DOS you. So there's
Given that's in a view, so if you could construct your code so that you were doing no for loops in your transaction-based functions, but just in your view-based functions, say that was going to execute and take, 1 second to execute, would a local, say, geth node say, look, this view function's just taken too long, I'm sorry, I'm not going to process it? Would it be happy?
They don't know until they do it.
Yeah.
Because it's not like a functional programming language, so they don't know.
Yeah, okay.
Alright, so that was pretty much it on the demo. So the other things, like I said, there's different scopes. So public can be read by the contract, private, internal, and external. They're pretty much self-explanatory. I did have a look at libraries quickly. You do have the idea of interfaces and multiple inheritance as well, which are just like general other languages. So if you have base classes, etc., you can just extend. All right, so the other housekeeping. Pete Robinson down here, security part 2. So it's probably going to be a sellout. So make sure you RSVP early for that guy. That's June 13th. I'm also doing a talk on Viper, which we'll do later in this series of meetups. So I'm liking Viper a lot more, so come along to that one to see the differences between it. There's my public key, if you want to email me. And thank you very much.
Thank you. Oh, thank you, Lucas.
All right.
That was great. All right.
On time.
And see you later, everyone who's on the live feed.